Hello everybody. In the previous couple of videos we derived the equation for logarithmic addition and logarithmic subtraction, and we arrived at this expression. So it's just a common expression where you take the logarithm of the pressure terms which are in the sound pressure levels, and you have a plus minus symbol where plus denotes you're adding the logarithmic value and negative sign denotes you're subtracting it. So now today I'm going to demonstrate certain additions and subtractions that you can actually encounter in your everyday life and tell you what the results are. So let's start with the first case, which is 100 decibel of sound pressure level plus another 100 decibel of sound pressure level. Now since it's not a linear addition, it's not equal to 200 decibel. Remember that. It's a logarithmic addition. Let's perform this logarithmic addition using this equation, and then for the other examples I'll just write down the value. So we go here where s equals 10 log to the base 10 power, s1 is 100, so 100 by 10 plus 10 power s2, which is also 100, so 100 by 10. So you write this down. This is 10 power 10, and this is another 10 power 10. So if you take the logarithm of this sum, you will get something like 10 by 10.3. So the final value is 103 decibel. So now you observe that 100 plus 100 is not 200, but in logarithmic addition it turns out to be 103 decibel. So any doubling of source is going to result in a 3 dB increase. Alright, so now what's going to be 100 minus 100? 100 dB minus 100 dB. Well, if you use the same calculation steps, just put a negative symbol here, you will get something like log of 0, which is not defined, which is like infinitive, which is not defined. And the the correlation here is that if you have in a real life example like 100 minus 100, you will not hear any sound. The sounds cancel out each other. Alright, so the next example is 100 dB plus 50 dB. So you use the same methods to calculate, and then you would end up with the answer which is exactly 100 dB. So 50 dB doesn't make a difference here whether you add it to 100 dB or not. The same applies when you actually try to subtract 50 dB from 100 dB. You still end up getting 100 dB because it doesn't make any difference here whether you have this 50 or not. So let's take another example. 100 dB plus 90 dB. Well, the presence of 90 dB signal here, in the presence of 100 dB does make a very little difference. You end up getting a value like 100.4 decibel. Not much. And the other case is 100 dB minus 90 dB. The value is still not very low. It's just again 99.5 dB. You can verify these calculations by plugging in the equation that I've shown in the video. And the final calculations are like, let's say you have a 200 dB noise source, which is like a rocket launch, and then let's say you have a rock concert going on near the rocket launch, so like 100 dB. Well, these values are going to add up logarithmically, and the end result is still 200 dB. If you think practically, it still holds true, because just imagine if you have a rocket launch here and then someone's playing a rock concert, you're definitely not going to hear the rock concert because you're just going to hear the rocket launch. And the same applies with the negative symbol as well. So 200 dB minus 100 dB is still 200 dB, no change. Alright, thank you for watching this video. I hope you enjoyed it. You can verify the calculations by looking into the link in the description below. I have included the equations and the derivations. Alright, thanks a lot. Bye.